Hi all. So today we will learn about simple notification service or SNS. So it's another serverless offering from AWS. So let's see what it is and why we need it. So SNS is a service which uses the publisher and the subscriber kind of uh, architecture. So it's a pub-sub service, and what it does is when a publisher sends a message, it will send the subscriber the message, so it will spread or replicate the message to all the subscriber. So here you can see that we have a bank user and we have attached an SNS in between, and then we have this backend application. One is for auditing, report generation, and transfer of money. So whenever a user sends a notification, sends an event, it will spread out that notification to all the service, or it will send the same event to all this. So let's say user want to transfer 100 bucks to some another account. So that message when received by SNS will get transferred or replicated to all this. So each of this service or the backend application will now receive this event. And the reason you would want to do this is instead of connecting the bank user application directly to all this, you would want to attach an SNS. So the reason is that now we have a single point of notification. So instead of notifying multiple application, we just have to make sure that single application or service gets this notification, and now it's up to that service to spread it out. And it is beneficial because let's say you notify this pay 100 account to the auditing service, and it audits that, but your application fails now and these two other services don't get that notification. So now there are integrity issues, right? And there is one more famous pattern, is a fan out pattern. So we have the same application here, but instead of directly connecting the SNS to the backend application, we attach an SQS in between them. So now the SNS will replicate or spread out the message to SQS, and then SQS will be connected to this. And we are doing this because now we also have the benefit which SQS provide, which is persistence of data. So SNS doesn't store data. Okay, as soon as it receives the event, it will send it out. But SQS can persist it for 14 days. It could change in the future. It can persist it for 14 days, and you can also do retries with SQS. So that's the reason you would want to follow this pattern. Remember, fan out pattern is to connect SNS with multiple SQS. Let's see how much time we have. Okay, so let's continue. So there are other integrations also which SNS supports. So SNS can integrate with both sides. So on the producer side as well as the consumer side. So on the consumer side, we have seen the fan out pattern. It can integrate with SQS easily. So it can send the notification to SQS, and then you can do whatever you want from there. And it can also integrate with Lambda functions directly, and you can do your processing there after receiving the notification. So the bank application we were saying previously, you can actually write the code here in Lambda function to generate the reports, do the auditing, or actually transfer the money from one account to another account. And on the producer end, we have S3 bucket. So S3 bucket also have events, right? So when an object is created, so for that you can create a notification to SNS. When object is deleted or when object is updated, so there is no real update in S3, there is just versioning change or the version change, but it can be considered an update also. So this type of notifications you can generate on your S3 bucket and send it to an SNS directly. So it also connects with DynamoDB, and so DynamoDB can again have the same kind of notification. So again, for this you can have the same kind of architecture here. So DynamoDB will also generate events like the object was created or object was deleted or some record was created. So for your bank application, if transfer of money does an update for in your DynamoDB, right? So transfer of money will actually do some transfer of money in a database, right? So that notification can be again sent to an SNS, and then again you can also do processing to verify if that transfer happened correctly, or you need to do something else in backend to manage your monies. So yeah, there are other integrations also, but in the banking world you would be mostly using this. So that's it for the SNS we have here. We can quickly go to the AWS console and see how to create an SNS. I'll pause it till I log in. Okay, so we are in the console. Let's go to SNS service and create your first topic. So SNS can be also called as topic. So let's create bank notification. Do next. So there is also FIFO, first in first out, as we had in SQS. So the message which comes in first will go out first. Display name could be banking related topic. We can just skip all of this for now, and we have our SNS. So let's see. So let's create a subscription. Okay, so we will create a simple SQS subscription, and we will create an SQS because we don't have any currently. So transfer money create queue. It should appear here, or I can just copy the ARN. And we have created a subscription. So let's go back to our topic, and we will send a notification. So you can see we have publish message here, and you can type here account 100 and account 2 500. So we can do minus 100 from account 1 and do a plus 100 in account 2. So it could be any kind of notification. We mostly use JSON in web development nowadays, so you should know the difference between JSON and XML. I'll create a video on that if you don't know. So let's publish it. So you can see the message has been published, and if we go to our SQS and see, we already have a message available. So poll for message, and in the body, where is it? Come on, show me the message. Let's copy it. There is some metadata around it, and let's see it here. So here is our message: account 1 minus 100 and account 2 plus 100. Okay. Okay, so that's how you create a SNS topic and create subscription. You can also use SDK to send out the messages. So see you in the next one. Peace.